Welcome and thank you for attending today's Crane Safety webinar. My name is Katie Parrish, editor of Crane Hotline, and your host for today's conference. If you have follow-up questions, comments, ideas, or suggestions after today's event, or for future webinars, please feel free to contact me at the end of the presentation. Crane Hotline would like to extend a special thanks to today's sponsor, CM Labs. CM Labs builds simulation-based solutions to help clients design advanced equipment and prepare for skilled operations. With CM Labs' Vortex software platform, clients are able to experience their product vision before it's a reality and train crews for safe and efficient operations before stepping foot on the real job site. Today, CM Labs is a leading vendor for simulation-based training in the construction industry. With more than 1,000 simulators in 30 countries using Vortex software, it has become the de facto standard for the industry. For 2 years in a row, CM Labs was named to the prestigious Deloitte Technology Fast 500, and it is among the fastest growing technology companies in North America. The company's markets are global, working with established leaders as well as emerging market trailblazers. A few of its prestigious customers include Honda, Hitachi, John Deere, Liebherr, and Volvo. For more information, visit cm-labs.com. Today's presentation is entitled 5 Tips for Successful Simulator Training. Simulators have been proven as a training tool that results in faster time to competency and more effective operator assessment. That's why more and more organizations are adopting simulation as a tool for training operators safely and efficiently. Before implementing simulation-based training for your organization, learn from industry pioneers about how to position your simulator program for maximum success. Today's presenters are David Clark, who's the Product Marketing Manager for CM Labs, and special guest Leslie Howlett, Global Simulator Instructor for Keyano College's School of Trades and Heavy Industrial in Alberta. At the end of the webinar, we will hold a question and answer session. If you have questions for our presenters, please type them into the chat box on your screen anytime during the presentation. Additionally, this is being recorded and can be accessed later this week on cranehotline.com. Before David begins his portion of the webinar, we want to kick off the session with an interactive poll, and we want your opinion on the following question. What objections do you see about simulation-based training in your organization? All right, poll's in progress here. Okay, we've got about 59%. All righty. David, what do you think about these responses here? What objections do you see about using simulation-based training in your organization? It looks like cost is too high, followed by operators, trainers not accepting the technology, difficult to integrate into training programs, and it's not realistic enough compared to real equipment. What are your thoughts on that?
Yeah, that makes sense to me. It's I'm not surprised to see that that is an objection that's sort of front of mind for many potential users of simulation-based training. The truth is that there are effective simulation-based training solutions for all budgets, and this is something I'm going to get into a little bit in my presentation. You know, they do range from desktop-based simulators to fully immersive solutions. Beyond the sheer pricing component, though, there's a cost savings element in terms of when you do use simulators, in terms of faster training, reduced equipment maintenance costs, reduced fuel costs, and of course safer training conditions all around. So I think with that, I'm going to launch straight into my presentation.
Great. Okay, let me get you the controls, and I'm choosing Make Presenter right now.
Okay. All right, is this all good?
No.
Okay.
One second, I'll take it back and I'll pass it back over to you.
All right, thanks. Okay, all good.
Okay, very good.
All right, well, thank you, Katie, and thank you all for attending today's webinar on how to make your simulator training program a success. I'd like to kick off my section of the webinar by introducing CMLabs to you briefly and then quickly debunking a few of the common myths surrounding simulators. As you can see here, and as Katie alluded to, CMLabs is based out of Canada. We've been around for over 20 years, and we're ISO 9001-2008 certified. We provide a range of training solutions, including, of course, a dedicated construction training lineup, as well as custom solutions for port terminal operations, and operational and tactical training solutions for the defense industry. Over 1,000 simulators all over the world are using our software, and that includes over 150 clients in more than 30 countries. Okay, myth number one. People who are new to simulators sometimes refer to them as just a game. But today simulators can accurately replicate the real behaviors of cranes, heavy equipment, rigging, cables, loads, and soil. That translates into real-world training and the objective criteria needed to evaluate operators. In this sense, simulators are serious learning tools. Let's take a well-established example. In the aviation industry, pilots take responsibility not only for complex and expensive equipment, but also for lives. Simulators train pilots for non-typical events such as machine failures and water limits, and pilots clock specified amounts of time in a simulator to maintain certifications. The reason simulators are good for flight is because they are verified against instrumented data in the field, and they're tuned with the input of subject matter experts. Similarly, effective crane operator training simulators accurately capture the behavior of rigging and hoisting cables from the load to the drum using actual engineering properties. And what this means is that they behave appropriately as lines are placed under tension or the load is released. And that means that all loads are going to pendulum, snag, and collide just as they would in the real world, providing valuable experience to students without endangering them or others. The advent of these professional-grade training simulators is the key reason that simulations become a primary tool for systematically addressing operator training and competency assessment issues. They have reached a level of realism that makes them an indispensable complement to modern training programs for all operator skill levels. In many industries, simulation-based training has been proven to reduce the learning curve and lead to proficiency in less time. For example, as you can see here, a study published in Chief Learning Officer magazine showed that surgeons achieved proficiency in 28% less time and made 6 times fewer errors. Similar training improvements were measured in the equipment maintenance domain, as well as driving and trucking, where we see fuel savings as well as a reduction in overall training time. So it's no longer just a game. The equipment may be simulated, but the training results are very real. Myth number 2. It's sometimes said that you can only use simulators to train for basic skills and controls familiarization. In fact, today's advanced simulators allow trainees to experience conditions and operations that are just not possible to train for on the real equipment. In addition, they can produce metrics that allow trainers to objectively assess how trainees are responding to certain conditions and measure any skill deficiency before it becomes a risk in the real machine. For instance, simulators can reproduce potentially hazardous situations which you would hesitate to introduce a novice operator to, such as a busy work site, shifting load centers of mass, blind lifts, or working around power lines. You can also simulate a variety of weather conditions, including snow, rain, wind and wind gusts, moving clouds, fog, and so on. Myth number 3 now, and this is the myth that addresses the poll results that we were discussing earlier, simulators are expensive. Well, considering the potential return on investment that simulators enable, in the end, simulators are not expensive. That's because using simulators for training, it lowers equipment fuel costs and reduces wear and tear on expensive equipment. Crane rental and lift companies can also keep their fleet in production while operators train on the simulator. In addition to fuel cost savings, simulators can also free up instructors to focus on other higher value-added tasks because trainees can work their way through simulation exercises at their own pace. As an integral part of a complete training program, simulators can produce safer, cost-effective operators who lift more efficiently and, most importantly, more safely. In addition to lowered training expenses and reduced accident rates, our clients have also found that they're training faster and that their operators are better prepared than without simulation. Using simulators to convert an operator from average or below average productivity to above average productivity can also improve the bottom line. In this scenario, companies can deploy simulators as both a training tool and an operator benchmarking tool by using the simulator's objective performance metrics to calculate competency scores. Furthermore, as I was saying earlier, simulators are available for all budgets, from desktop systems for the classroom to immersive full mission simulators. We're talking about price ranges from a few $1,000s to over $100,000. My point would be that in the end, simulator costs have come down to the point where it's proving more costly to defer simulation-based training than to adopt it. And with that, I'm going to turn the controls back to Katie so she can queue up another poll for the audience before we launch Leslie Howlett's presentation on 5 tips for making your simulator training program a success. Katie?
Great. I will grab those, and we will launch into this second poll here. Okay, we have our second poll is, what do you think is the biggest potential benefit of simulation-based training? Lower costs than operating real equipment, can learn skills faster, objective assessment, train on more equipment types, or better prepare for hazard scenarios. Okay, we have about half of our respondents who voted, a little more than half. Okay, I'm going to close this poll. I think we've got about everybody that we're going to get and share the results with you all. Leslie, would you like to take a look at these poll results and give us your feedback?
Well, it's not surprising that better prepared for hazard scenarios would be the #1 choice. It actually gives, from a student perspective, it gives everyone the opportunity to learn in a hazardous scenario at the same rate. Simulation keeps the environment the same throughout the scenario. With real application, student #1 could get in when the sun is shining, student #2 when it's raining, student #3 when the wind is blowing. So it's a little bit hard to get everybody in there when there's freezing rain across the windshield. And of course there's heavy fog conditions where with the simulators you can actually put them all into the fog and everyone gets an opportunity to participate in that type of lift, not just the lucky one, you could call it, in a learning.
Okay. I'm going to pass the controls over to you if you'd like to go ahead and get started on your presentation. Let me hide this real quick.
Well, good day, everybody. My name is Howlett. I'm the mobile simulator instructor at the School of Trades and Heavy Industrial at Keyano College. Welcome, everyone, and thank you for joining us today. Keyano College, we're actually located in Fort McMurray, Alberta. We provide specialized training to over 2,800 full-time students and 13,000 part-time. Because of the unique demographic that we have, our learning is forever changing because we're in the middle of the Athabasca oil sands. We chose to use vortex simulators as one of our teaching tools, mainly because it gives every student the opportunity to learn the same in different areas. So why is it that we do what we do? Well, every operator knows that they have the responsibility of safety of a lift on their shoulders, and sometimes this creates some nervousness when it's time to go and make a lift for the first time. So we find that it's important for us to provide the operator with knowledge and experience to operate and do that lift safely. When you're looking at how the root cause of accidents, of course, there, as you can see in order here, there's inexperience with the equipment, which simulators give the student the opportunity to learn muscle memory, where every switch is, how the levers control, and prepare themselves for that lift, becoming more familiar with the equipment itself. Of course, the lack of knowledge of machine capabilities, the proper rigging, site conditions, lift planning, you can actually give the person an opportunity to know that machine and know the lift that they're doing. With regards to lack of experience in terms of changing conditions and or challenging loads, as I said earlier, what we like about it is that our students get to take that scenario, and every one of them gets equal opportunity at performing the same lift in the same conditions. And of course, we can change those conditions. The other one, of course, operator complacency will sit in. So it's not just for the new learner, it's also for reevaluations and onboarding evaluations. You know, you have a person that you're about to hire. You know, from a HR standpoint, I guess it gives them an opportunity to find out what the person really is like, and probably help them before something happens. You can catch, you know, if they're understanding that every load is a safe load, a safe lift. And also with simulation, it builds competency. There are some attributes of good operators, of course. Number one is they know what to do. Every operator, when they sit in the seat, I mean, they've already had time on the ground. They've had time with the other operators, and they've been already molded. But again, it's nice to be able to sit in that seat and do a lift that you've never did before prior to doing it in real time. Also, they know the timing of control movements, and simulation actually gives them a chance to practice that and again develop those muscle memories to make them more efficient in their job skills. Every operator, of course, know their abilities and limits, and of course, especially when you're making the lift for the first time, again, that nervousness creeps up. But by giving a chance to practice it over and over again without the hazards is really what makes it more comfortable for the operator to work. And of course, they can also anticipate and react to events before they become issues. When you look at, I'll just take it from a vehicle point so that everybody fits in on this. We all have never had a tire blowout, but if we had a tire blowout, maybe the first thing our body would do to react would be to hit the brake, and it's actually the wrong thing to do. So same thing with a crane. You know, once that load moment is changing, the best thing you want to do is you know, take that load off and get it to the ground, or get it to somewhere where it's controlled again, the simulation gives you a chance to practice that. And of course, our ultimate goals with building competency, as I said, operators, we're known for quantity. We're able to do reliable, they are reliable assets on the job site, and we want them to be confident in the job and to be able to incorporate practice lifts beforehand is one of those skills that the simulators can do. So why we use simulators? As a college, of course, we use them as our learning tool. It complements the rest of the program efficiently. The students get to acquire skills and confidence in a safe, low-stress environment. Here in Canada, of course, we have what they call a Red Seal program, where they go and they do their first year, second year, third year. We've had students come in, doing their third year and probably only operated a crane as a safety crane over a confined space or something, and that was the extent of their experience. With the simulators, we're actually able to give them practice lifts, lifting columns, loading into buildings, offloading trucks, placing things in the ground, which gives them more insight on what actual functions the crane does, and gets them prepared and setting everything up for the job. And of course, practicing challenging lifts in different conditions. Again, we get to give every student the same conditions. We can put that wind, at a 45 degree at 30 kilometers an hour, and we can have every student practice that lift with a 45 degree with 30 kilometer hour winds, which really gives an awesome learning curve. Instead of, as I said at the beginning, some students out on the iron, one student will get a nice sunny day, then the next student gets it rain. There's advantages and disadvantages. You could look at it, but really the person that didn't get the rain actually has the disadvantage. So, and of course, being able to lift in the dark, also in the blind, and helps to build those communication skills with your riggers as well. And of course, training during inclement weather or machine maintenance. You can do a thorough walk-around inspection. One that I think about is our RT crane. The student can confirm if their pads are out, if their outriggers are positioned correctly, just by becoming an avatar and stepping outside the machine and doing a walk-around. So it does give advantages that way. And of course, one instructor can provide engaging training experience to multiple students. David mentioned earlier that they also have desktops. Keyano actually has the full immersive systems, which have motion-based and 5 screens, which allows for a bigger integration for the students to participate in. So what we do as a college is we have our students, one observe, one operate, and then the other one is the rigger, which is also given signals. So it gives also a sense of teamwork and allows the people to participate as a team, which would happen out on in the job site. Also, with simulators, of course, you got less wear and tear on the actual equipment. We reduce fuel costs. I mean, environmentally, 0 emissions. There's no emissions going out there with the equipment. There's no annual NDT testing, no oil changes that need to take place. You could probably look at it as a disadvantage as well, because the operator is not getting a chance to do that. But a lot of operators will get that in their first and second years anyway, as oilers and riggers. So, and of course, being in a simulator does reduce stress levels for students and instructors. One is a student will get a chance to, practice a lift that they probably wouldn't get to practice for a couple of years. And then, of course, for the instructors, they're not looking at the student pulling the lever the wrong way, or hitting the E-stop, or letting go to brake. They're actually it reduces the stress on the instructor in so many ways. And of course, as pointed out a couple of times, it measures skills objectively. So each person gets to learn the same way, giving everybody the opportunity to look at what they did right or what they did wrong and discuss it. One of the features that myself, we look at with the simulators we have is a record and playback. So we can actually have a student do a lift, and then we can sit back as a group and we can watch that lift taking place and identify some things that we will do differently next time. You know, what kind of rigging would you use, even though it's not physically put on there, but what kind of rigging would have you done? You know, what would you incorporate in measuring those skills and getting things right the next lift. So how do simulators bridge the gap? A realistic simulator, of course, allows novices to move from the sim to the real machines without having to unlearn bad habits. I always tell my students, you're not going to learn it my way, you're going to learn it the right way. And that's the great thing about it. Simulation gives the student step-by-step instruction on the right way. So this means the learning curves on the real machine is less intimidating. When they hop in the machine, they're not worried about how it's going to be integrated, how the machine is going to function, where the setup is going to be, how communication is going to work, things like that. Realistic simulation is key to developing, of course, good operating habits early, before even getting on or into the machine, and of course reducing time to competency. We find what happens is that the more seat time the student gets, the more the muscle memory develops to the point where you know, it's not even a thought process anymore. That load moment changes. The student already has made the changes for that moment. They're not actually thinking about it and wondering what they got to do next. And again, as I said earlier, it reduces stress on both the student and the instructor. So in a typical classroom setting, of course, you know, it's safe and controlled, it's enclosed, you got a comfort zone, everybody has a routine, you know, this is how it's done, this is how it's going to happen, and then of course you just run right out to the real equipment, and now you're trying to experience that full impact of real life operation, you know, making sure nobody gets their hands, you know, pinched in a rigging, making sure that communication skills are being talked out between the rigger and the operator, and you know, everybody knows their job set. The great thing about the gap itself is bringing in the simulator. The simulator allows the student to practice those skills that they were taught in class, then of course hone in on the skills depending on what type of lift it is. For us, of course, we have tower cranes, RT, and lattice boom crawler, so we get to have our students, depending on what program they're taking, to practice either of those three, and allows them to build confidence in those lifts, allows them to, you know how the controls are going to function, how the LMI is going to set up, you know, getting things ready before the actual lift. The lift itself, as safe as it has to be, that's probably the least amount of time that you're actually going to be on the machine is that lift. It's all the pre-planning in advance, you know, making sure that the right rigging is there, making sure that you've done your safety checks, making sure that your machine is safe, your construction site is safe, and of course the person themselves is safe. And then of course testing, it allows the instructor to test the students, and of course the students can self-test as well, you know, see what their limitations are. You know, and be able to take those out when they move out into the field. And of course, experiencing hazards. Again, I've mentioned it twice, but it's one thing that I believe in with simulation, and that is the change of environments. I can't control the environment outside, but in a simulator, I can control that environment. I can make a sling fail. I can give you a crosswind. I can give you heavy snow. I mean, you know, I can give you engine failure, things like that. What is it that the student's next move is going to be? Where, you know, when we get out into the yard or the real equipment, if that sling breaks, that's the time it's not the time to be thinking, it's the time to be acting. So at least in a simulator, it gives the students a chance to think in a safe, controlled environment. So tip number one when it comes to simulator training is a structured approach that's required. It's not just taking the sims themselves and say, okay, well it's cold out today, or we got a machine that's down. Okay, let's just stick you in a simulator and give you a bit of seat time. What you want to do is make it a part of your program. So you have your theory, you have your simulation, and then you have your practical. And you can actually go back and forth to all three. You don't need to do them in that order. You can actually do some theory, some simulation, and then move on to practical. And if the person is out there doing practical and you see that they're weak in an area or they're not understanding it, you could bring them back to the simulator, get them to do it over again until they've got it correct, then put them out to the practical again. And then of course you can repeat that process. So it actually gives everybody an advantage. Tip number two, of course, is simulator training is a two-way street. And for myself, I've been using simulators now as one of my training tools for over 5 years. And I find that the training experience on the real equipment should always reinforce what's learned on the simulator and vice versa. So I follow up with my students. I find out, hey, what advantages did you get? Just in recent years, we've been doing a tower crane program with the Alberta industrial trainer, AIT, and what we've been doing is we've been going to a couple of different colleges given the program. So we went back to these students and asked them, what is it that was an advantage or a disadvantage? Again, depending on the person, some of them were glad that they got to do certain lifts because they actually got them when they were out in the real world. Others, of course, the biggest complaint we always get back, and everybody will hear this is, well, I don't get to do the rigging. I don't get to do the rigging. Again, that's probably the only part of the simulation that's going to be a downfall. But it does create a positive feedback loop, because the more that you get back from your student, the more that you can give on to the next class. So we've taken feedback from one class and made the next class better. So with simulators, you got to be always willing to change in order to make sure that the program is working at its best and highest capacity. So it's change. Simulators are change to some programs. Simulators are a change to a lot of people. But even once you start using simulators, there's still going to be constant changes because technology changes, simulators become more integrated, and you've got to be willing to take it to the next step. Then tip number three, of course, take advantage of the natural benefits of the simulator. When you're looking at it and you're going, okay, well, how am I going to integrate this into the program? Get your students to give you feedback on what they've experienced, and then try to bring some lesson plans around to relate to their experiences in the workplace. Then, of course, there are things that trainees can learn better on a simulator than on a real equipment. They'll get to know what their personal limits are, and of course, as we mentioned before, experiencing hazards and how to react to them, it pays for itself in the long run. Not just with new operators, but even with experienced operators, advanced operators can get a chance to practice their skills and hone in on what they really need to learn. Of course, tip number 4, with the simulator, of course, you can create an environment for peer-to-peer assessment and learning. It's great. Like I said, we have a record system that we actually take and we watch it with our students and see what could be changed in that lift. What was the load moment? What can we do to change it? Was it too much aggression on the lever? Was it the LMI wasn't set up? Or of course, if the instructor or it chooses to create hazard, what is your reaction to it? And you get to practice that over and over again until you've mastered that reaction. Of course, this maximizes trainer resources as well as learning retention. You know, your staff-wise, you're not going to burn them out as much, you know, because now they're going to be able to integrate the simulators, which gives them that reprieve, I call it. I've sat in the vehicle, I've stood on the pad, I've watched people operate, and you know, stress levels are a little bit higher. Where with the simulation, it sort of takes away a little bit of that stress and allows you to be able to watch the student. And of course, this is safer and easier than on real equipment, no matter what takes place. You know, a pendulum, you know, if there's a minor collision or a major collision, you know, looking at what could happen the next time. And a lot of the time with our students, when they're in the rigging seat or the instructor station, as we would call it, they get to maneuver around and watch how everything is working. So as their counterpart is working, they get to see what's taking place, and then they can take what they've learned from their observation and apply it to their skills when they get in the seat. Tip number 5, establishing benchmarks, of course, whether it's part of a competitive environment or performance assessment. Making sure that you have those benchmarks in place before starting are very important. You know, bringing it an introduction to the simulated environment. How you introduce simulation to a person can affect them basically for the rest of their simulator experiences. You know, the word video game came up this morning, and it's not a video. You know, the cables themselves, they react the same as if they were on another on a piece of equipment. You know, the load moment does change. You can feel the change in the equipment as the load is being lifted. You can feel the tension on the boom or the tension on the cable. So, you know, making sure that the person understands that, you know, don't look at it as an actual game. You got to look at it as how it will help you in learning. And of course, this also allows you to calibrate operator performances as well as your training. I said it earlier, and I'll say it again. You know, your students are your best critics. Open up to them, take the feedback, and make changes accordingly. These are the ones that are sitting in the seats. They see things. You know, if they point out something, don't take it as a you know, as a negative. Take it as a positive and go, okay, yeah, we got to look at this. You know, maybe we can go back to the designer. Maybe we can, you know, get things changed, or maybe it could be a lesson plan change. Okay, well, we're not going to do this the first step. We're going to do something else before we move into this step. And the last one, of course, objective matrix provided by the simulator also allows self-assessment on the part of the trainees. You know, they get to look at, you know, their pendulums or their collisions, and of course, in an excavator mode, you know, they can look at, you know, their bucket height, or, you know, how much they're getting per bucket, or what their production is. So when you're looking at the different types of you know, assessments themselves and self-assessment, the student themselves, because they're getting immediate results, they'll push themselves harder. We're in a typical classroom setting or out in the field, the student's working all day, sometimes all week, and then on Thursday or Friday, things are discussed. With this, they're getting real-time feedback, and they actually get to challenge themselves through the objective matrix. I'll say thank you.
All right, thank you, Leslie. We're going to open up the floor to some questions, and I'm going to go ahead and put, if you can go over to the next slide over, I think there's contact information. There we go. If you have any questions for today's panelists, after the presentation, please feel free to contact them at these numbers or email addresses. We have a few questions from the audience here, and if you have any additional questions, please feel free to send them. First of all, for David, how can simulators accommodate team training?
Yeah, that's a good question. Today's professional grade simulators, they allow for coordination not just in terms of signaler and crane operator, but also for such advanced operations as tandem lifts. We often find that the opportunity to perform simulation-based training as a team beyond the sheer training value in terms of competency also allows trainees to develop better communication skills between them. And in the practical environment, of course, what this translates into is a more efficient lift, and that translates into bottom line benefits.
Okay. And also for David, how does virtual reality tie into simulator training? We're hearing a lot about that, and maybe how do they compare?
Yeah, there's virtual reality. It's the hot new thing these days, or certainly last year. What's happening now is that industry analysts are sort of scaling back their projections for the popularity of VR training, and there's a really important reason for that, which is that it's a very isolating technology. Typically, when you are in a virtual reality environment, you're locked away from the environment, from the real environment around you, and that's an issue. There are also other issues with virtual reality-based training. An associated condition called cyber sickness, which is the result of training in a VR environment for too long. It can make the real world look kind of skewy when you emerge back into it. And in fact, there are some recommendations coming from the defense industry that you not operate heavy equipment for a certain number of hours after undergoing VR training. So that sort of puts shackles on the notion of the idea of using VR-based training for heavy equipment operators. But that said, there is, I believe, a place for it in the training industry, and that's in combination with AR or augmented reality. These technologies, of course, are fast developing, and it's early to tell yet where the most appropriate focus is going to be in terms of training.
Okay, great. Well, we've got several questions, and this theme has come up a few times here about veteran operators or reducing time to unlearn bad habits. How do veteran operators deal with simulation training differently than novice or new operators, and can simulation-based training be used for retraining? Leslie, would you like to go with that?
Well, a veteran operator, of course, they already have their habits and their skills in place, so they're probably more apprehensive in actually, getting into a simulator, and they probably don't think they can learn anything from it. I will use an example that I was told. On the excavator side, we had a 20-year-old veteran that's been operating the excavators 20 years, and the first couple of times that he showed up for his evaluations and retraining, he was very apprehensive, didn't like it, and basically he was told, listen, just take it easy for now. We're going to just introduce you to this. We're not going to capture your data or anything. We just want you to learn from it. By the fourth visit, now each visit usually is about an hour long. By the fourth visit, which means it was 4 hours, this person actually went back out into the field and was telling everybody else about the simulators, saying how he improved his production skills. What he thought was good by loading up the bucket too much, what was happening was he was actually reducing his production time because he would have too much material in the bucket. His rotating took a little bit longer. It was harder on the ring gears, everything else. And through the simulation, he actually improved his production time. So sometimes with a veteran, you really got to, let them know that, hey, let's learn about the simulator itself first. Being honest with them and tell them, no, it will never replace the real equipment is the very first thing I would tell them. Don't let them, don't tell them, hey, this is the way we're going to do it. Make sure that you tell them honestly, no, it can never replace the real thing, but you can walk away with something. And after 4 visits, this operator walked away excited about it and couldn't wait to return to hone in on his skills even better.
I'd sort of like to echo that. I think it's something that we've observed in the field that, there's some crane operators who are not operating the same crane day in and day out. There are some operators who go for weeks or even months between lifts. And what the simulator serves for in that case is the opportunity for them to shake off the rust before getting back out into the field, or it allows them to rehearse a lift that they may not have performed before.
Okay, we've also had a few questions about the percentage of time training on a simulator versus a real crane. Is there any comparison regarding the time gained with a simulator? And also, does it replace real crane simulation or real crane operation?
I would say that typically our clients use simulators for 25 to 50% of the seat time, but in reality, often it does not mean less time on real equipment, but more practical training time in total, since trainees have easier access to simulators. And what that means is that overall time to competency is reduced while the trainee is obtaining a better learning experience. So we see simulators as a complement to training on the real machine, not as a replacement for it.
Does it satisfy OSHA's upcoming crane operator qualification or certification requirements?
Is that a question for?
Either one of you, Leslie? You may not be dealing with
I mean, obviously, it's like flight simulation. I mean, it's probably going to take a couple more years for that to actually take place, where it's probably going to be mandatory at that time. Maybe in a couple of years, you'll have to have so much seat time in the simulator to maintain your ticket. Who knows?
Yeah, we're seeing a lot of change in the industry as far as the credibility of simulation generally, and that's sort of going hand in hand with the advent of professional grade simulators. So the construction industry, the safety industry as a whole is starting to see them as a viable tool, either for training or for recertification. And we'll see what OSHA does with that.
Maybe this kind of ties into CM Lab's portion for graphics and computing. What's a good rule of thumb for upgrading cycles on simulators?
Oh, that's a good question. I think that part of the cycle can be tied to the upgrade cycle for some of the hardware itself, in terms of the computers and the graphics cards and so on. So in that sense, of course, there's always the next best thing, which you can incorporate into your simulator. At the same time, the simulators that we develop are designed to last for years of training. That said, we do have certain maintenance and support programs that I'm happy to talk about sort of one-on-one that allow people to benefit from upgrades to the supporting technology.
Okay, the person who asked that question, if you want to contact David, his contact information is on the screen if you need more information on that. And one other question about training modules. Are there pre-programmed training modules, or this person's asking how would a college start from scratch with simulators?
Maybe I'll let Leslie talk first to that, and then I can tag on, since Leslie has first-hand experience with that.
Can you repeat that again, please?
Sure. Are there pre-programmed training modules, or how would you suggest a college go about starting from scratch?
How can a college start from scratch?
with simulators?
Well, we did start from scratch with the tower crane program. So, what we did was we had, crane experts come in and start looking at, different types of material that had to be covered. Took the outline from the, the industrial training side and looked at what were some of the objectives in the program that could be met with the simulator and what theory could be complemented with that to enhance their learning when they did step into the simulator. So we had, people from industry, we had actual crane instructors, and then of course we had people that worked with simulators before that could see some of the potentials of the simulators to be incorporated into the program.
Okay.
Yeah, I'll just add on. Sorry.
Sure,
I'll just add on.
No, go ahead.
We do have training modules for different equipment types, whether it be sort of lifting equipment or earth moving equipment. We do have a catalog of equipment that I can direct you to on our website.
And Leslie, to what degree do you incorporate load charts and chart reading activities in simulated crane training sessions? Do you tie them in at all? Did we lose you, Leslie?
Yes. Well, we do it the load charts themselves. We do from a theory perspective before they're actually put out into the simulator itself. The only example that I could really give you is tower cranes, where we look at the radius, and of course we look at what percentage of load we're going to pick up, and we watch our LMI as we're picking it up and know what the limitations are. So it's basically it's a pre-lift plan. Get what that load is actually lifting at, what's the maximum radius, and then planning your lifts from there.
Okay. And this person also had a follow-up question with that. Kind of ties into it. What instructor to student ratio do you find has worked from your experience?
I'm comfortable with in our setup that we have. I'm comfortable to have up to 6 students. In the lesson plans, you can take those 6 students and you can give all 6 of them a job to do. So you have one person that's your observer, your safety person. You have the operator, and of course then you have the rigger that's giving communication to the crane operator while they're on the instructor computer.
Okay. How much time do you feel is needed to get students oriented before they can be self-directed?
I myself, depending on age.
Okay.
If you got someone that's grown up in the technology era and embraces technology and loves how it works, I mean 4 to 6 hours, they're almost telling you things that could be done with it. When you got someone of an older generation, it's taken me, believe it or not, up to 3 days to integrate somebody, mainly because of pushback, right? I mean, that's really where it comes from. But again, it's introducing it correctly at the beginning, making sure that you're not trying to replace something. As David said, you're telling them that it complements it. They're going to learn something here, and tell them all about simulation itself and other areas that it's being used in. So really getting it out there that, hey, this is going to help you. And once they get in there and they start getting this real-time feedback, and they're starting to see that, wow, I'm getting results right away. We all like to know what we're doing immediately. We don't want to hear 2, 3 hours or 2 or 3 days on the road. I want to know how I'm doing now, and that's one thing that simulation does. It captures the data right away.
Okay. Final question here. What's the ratio of simulator training time to real equipment time for a total beginner? Is there a certain time that you would suggest, or it's dependent on the person?
Yeah, I mean, you know, I mean, we ourselves, I mean, you know, we usually, if the student gets 10 hours of seat time, you can see a big change in their operating skills. So that's what we stick with, you know, is our first 10 hours. You know, anything less than that, you can find them. I mean, you know, we've had students that hopped in and, you know, 3 or 4 hours later, you're saying, wow, like you must have done this before. And they'll say, nope. So.
Sure. Okay. Those are all the questions that we have from the audience today. Thank you, David. Thank you, Leslie, for your expertise. And if you have follow-up questions afterward, please feel free to reach out to our presenters today. And I'll put my contact information up on the screen as well, just in case you have some ideas for a future webinar or you have questions that we can answer for you. Thank you all for coming and attending today. We appreciate your support, and have a great rest of your week. Happy Valentine's Day.